Welcome to Emilac online tutorial. Before us is this question in vibrating string, and the two questions being asked is to calculate the frequency when the tension is reduced to 1/4 of its original value, and the second one is the tension required to produce a note of a frequency 600 Hz. But the question tells us that the frequency of a plug string is 800 Hz when the tension is 8 Newton. Alright, what we just need to do here is to get the relationship between the frequency and the tension. Yeah, the frequency and the tension. And take note, we are not actually giving any other parameter, length or mass. Now, but let us recall that the relationship between the frequency, the length, the tension and the mass of a string is given as this relationship. Okay, all right. Now, so from here we can actually get the relationship between frequency and the tension, and from here we can say this is F equals to now the square root of what? T. Now, but sorry, we can just say this is the relationship. All right, so removing this sign of proportionality, we can say this is that F equals to K T. Now, where K is the constant parameter that bears the ratio, the value of this mass and the length. All right, now, so with this is the formula we're going to use to solve this. All right, the frequency here is given as 800, now equals to K, our constant, the square root of the tension, which is what? 8. All right, so and with this we can actually put this, simplify this, will be 800 equals to this one be K, that'll be 4 times 2, so 800 equals to 2K. Right, so our K here will now be dividing both sides by 2 root 2. So here you have 800 over 2 root 2, which will give us 400. Okay, you have 400 over root 2, and take note, you can't leave this because of the sword. Then K will now give us 400, which will rationalize, and by rationalizing we multiply both sides by root 2, so which will give us 400 root 2 over 2, which will at the end of the day give us 200 root 2. All right, so this is the value of the constant. So, and as such, now we will actually implement this in the subsequent question. So now we are told now to find the frequency when the tension is reduced by, so when the tension, where is the tension? Our tension is 8. So when the tension is reduced by 1/4, so 1/4 of 8 Newton will give us 1/4 times 8 Newton, and which will give us 2 Newton. All right, so bringing back this relationship, that F equals to K the square root of T. Now we have to find the frequency, so F equals to 200 root 2 times tension. So here we have root 2. So root 2 times root 2, that will give us 2. So here you have 200 times 2, and that will give us F equals to what? 400 Hz. Right? All right, so the next question is number 2, and by so doing, the tension required to produce a note of, so bringing back this relationship, we have K the square root of T. So since we are looking for the tension and the frequency is given as 600, so 600 equals to, then our K, which is our constant, is 200 root 2 times root T. So dividing both sides by this, So here we have that 600 over 200 root 2 equals root t. So if we cancel out this 2 here 1 2 here 3, you are left with what? 3 root divided by root 2 equals root t. Alright, we can just square both sides. By squaring both sides, you have 3 over root 2 all squared. When we square this one, we are left with t. So at the end of the day, just come over here. The t will now give us the square root of 3 is 9 over the square root of the square of this square root of 2, where you have 2. So at the end of the day, our tension is what? 4.5 Newton. Final answer. Alright, if you love what I've just done, can you subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in chemistry, physics and mathematics. Thank you and God bless you.